Today we are looking at solving logarithmic equations, and for the most part it is very similar to what we did with solving exponentials in the last lesson. First things first, if we have a log on both sides of the equation, a log with the same base, remember if there's no base written, we assume it to be base 10, our normal writing number system. If so, the logs are the same, I can just eliminate them and look at just what's on the inside and say 3x equals 2x plus 7. And then I just solve for x like normal, subtract 2x, I get x equals 7 as my answer. Now, in this one, number 2, I do not have logs on both sides, so I can't just cancel things out. What I need to do, I have two options. First of all, I can try to rewrite this. So I'm going to do this over here. If I rewrote this as we did back in the previous lesson, I would rewrite this as the base to the exponent, or to the answer exponent power equals whatever's on the inside. And then I would solve for x. So I would have 9 over here, subtract 4, so 9 minus 4 equals x, so I should get 5 as my answer for x. Now, the other option is sometimes it looks a little bit more messy than that. I could go and do something like this. I can take the inverse operation. Well, if the base is 3, that means I need to take each side and have it raised to the 3 power. What that does is it makes these guys cancel out, and I'm left with just what was on the inside, x plus 4 equals 3 squared. And guess what? It's the exact same thing that we had over here. So x would equal 3 squared is 9. I needed to subtract 4 from both sides, which gives me x equals 5 as my answer there. So you have two different options, whether it's rewriting it or taking from your exponent, from your base, raising it to that power. All right, and number 3, do we have logs on both sides of the equation? No, we do not. So we should be looking at something like number 2. However, I cannot just go raising everything to the 4th power. I cannot do that. That is not a legal move. I need to do something else first. What I need to do first is I need to make it so it's only one logarithm on this left side. How do I do that? I need to condense it. It's going to be log base 4. When I have a subtraction on the outside between two logs, it means I can combine them with division of the two inside, x over x minus 1. If this was addition here, then I would have multiplied x times x minus 1. It's just one of our rules. Now I can take each side and raise it to the 4th power. That leaves me just x over x minus 1 equals 4 squared, which is 16. I'll now say I'll multiply both sides by this denominator to get 16 times the quantity x minus 1. So I have x equals 16x minus 16, and I will solve this and get 15x will equal a positive 16, which means that is an answer out of room. X equals 16 over 15 as my answer. Alright, and the last one. Natural log. Remember, natural log is the same as saying log base e. So that means I need to take each side and raise it to the e power. Hopefully I can write e's better than that. So, when I take that, those cancel out, I'm left with x minus 2, equals e to the 5th. Anybody know what e to the 5th is? Nah, I really don't care. I'm going to leave it just as e to the 5th, just like I would leave answers of pi as pi. We're more accurate that way. Just how do I get x by itself? I need to add 2 to both sides, so my answer is e to the 5th plus 2. If I wanted an approximation, this approximates to 148. Adding 2 more gives you approximately, I think it's 150.1. But again, this answer right here would be the answer I would care most to see. Alright, that's how you solve log equations using exponentials to help undo your operation.